So here again we see the relationship and connections between grams, moles, molecules, and atoms. Now we're going to look at a problem where we determine the number of molecules in 50 grams of water. So we're given units of grams and we're trying to find molecules. Notice that when we start with grams, we first have to use the molar mass to convert to moles, and then we can use Avogadro's number to go from moles to molecules. So in this case, our starting units are grams because that's the number we're given. So we start with 50 grams of water. We know that grams needs to go on the bottom, and we're trying to convert to moles. So 1 mole goes on the top. We're using the molar mass of water of 18.02 grams per mole. Next, we need moles on the bottom because we need moles to cancel out. And we're going to have molecules on the top, and we'll have 6.022 times 10 to the 23rd molecules per mole, because that relationship is always true regardless of the identity of the substance. Now we can look at what units will cancel out. So grams cancel, moles cancel, and we're left with units of molecules. So now we can do our calculation and take 50 divided by 18.02 times 6.022 times 10 to the 23rd, and we get 1.67 times 10 to the 24th molecules. Now let's look at an example where we take it one step further. How many atoms are in 50 grams of water? Looking back at our diagram, we see that we're starting with grams. We're going to use molar mass to convert to moles, Avogadro's number to convert to molecules, and then look at the ratio in the chemical formula to determine atoms. So in this case, we're going to go all the way from one end of our diagram to the other. Problems can start at either end, or they can start anywhere in the middle and work in either direction. But these relationships will always be true. So we're starting with 50 grams because that's our given value. We know we want to cancel out grams, so we're going to use our molar mass, 18.02 grams per mole. Now we have moles in the numerator, so we need moles in the denominator in order to cancel out. And we're going to go to molecules, so 6.022 times 10 to the 23rd molecules per mole. And next we have to go to atoms that are in the molecule. So we know that we have one molecule on the bottom. So in one molecule of H2O, there are 3 atoms. And we know this because if we look at this on the molecular level, we know that H2O has a subscript of 2 for H, so that tells us there are 2 atoms of hydrogen and 1 atom of oxygen for every molecule of water. So our relationship comes directly from the chemical formula. Now we can cancel out units of grams, moles, and molecules, and we're left with units of atoms. And when we do the calculation, we get 5.01 times 10 to the 24th atoms in our 50 grams of water.